Hello, welcome and ladies and gentlemen to another kata on Code Wars. This time around is 8Q. So Binary Life is a channel that teaches you how to code, especially beginners, and so that you can see the thinking process and how we got to the solution. So without wasting much time, let's get to solve this 8Q kata, which is about find the position. Now let's read it rapidly. When provided with the letter, return its position in the alphabet. For example, if we are provided with letter A, let's return 1, something like this. If it's B, it should be a position of alphabet is 2. So I am going to use something called index of to solve this. For example, this is my Node.js console. If I have let's declare a string to be something like this, text test. If I do something like test.index of s, what does that mean? It means let's say s, it means inside the string, in which position does x occupy. So we can see s occupy index 2 because index has 0 base, so it's 0 1 2. That's it. Now we can use these this method to solve this. There are many ways to solve it. I'm just going to use this. Imagine I have my alphabet made up of strings. Let's start at 0 so that it will be easy at the end. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Now if we have that and we are given a letter in this alphabet, we can see that A is at index 0. So what can we do? We just need to return from our alphabet the index of the letter that was passed as a parameter. If it's m is going to be at the right position here, given that we have considered the 0 base index here. If we never consider the 0 base index, if we are started at A, it means we put index of letter plus 1, something like that. So they say the output is supposed to be this sentence. Let's frame it very well, something like this. Instead of 1 here, I'm going to put this something like this. Now that's a tilde I just put there. This is the tilde back tilde character. You can also use that to put strings, and this is a way to put variables inside the tilde. Now I can replace all of this alphabet directly with the string if I want to put it on one line. So let's test, and our code is very correct, and let's just execute it so that we can submit and see what approaches other developers have come up with for this particular exercise. All right, we have the same thinking here, and this is plus 1 like I was talking about. This is car code. Car code is using the ASCII character. So now he takes the letter, so here he has changed letter here by L. So if we are given a letter, we're going to get the ASCII character minus 96. There's a math behind that. You can check it. Actually, we can check it. Let's see something. Let's test it. So this is car code add. So if we're given let's say A, the ASCII code of A is something like this. It's 97. It means A starts at 97. That is why we say minus 96. So if we're giving A, is going to be 97 minus 96. That's 1. And it goes the same for B. That is why it's 96, the base. That's it. This is the same scenario. This one, he just makes sure he lower cases the letter in case it was given in capital letters. That's just for verification. Now this is in the form of an array. This was so much. I think he forgot that we could put it in the form of a string here. Index of gives the same index, be it for array or string. So this gives much work for typing instead of doing something like this. Okay, well, basically that's the same. And I think we're done for now. Everybody is just about the same scenario. This is tons of inefficient code of if and else. I think those who are writing best practices here are just for fun. Let's just join the fun. This is crazy. Okay, that's it, guys. So see you on another video for another solving for another algorithm.